So the following says to rewrite the following without using scientific notation. Okay, so in this first one, we're going to do a couple different things. So we've got 7.2 times 10 to the third. So again, remember, exponents keep track of how many factors of 10 we have. So this means 10 times 10 times 10, which is 1,000. Okay. So if we look at what happens in our number system as we multiply by 10. So let's take this number that we've started with here, 7.2. And if we multiply that by 10, we get 72. Okay, so basically this decimal moved to the right 1. And if we take that and multiply by 10 again, that decimal place has moved to the right yet again. And if we multiply that answer by 10 yet again, it moves that decimal place to the right one more time. Okay. So as we take 7.2 times 1,000, we can type that on the calculator, or we can think about, again, every time we multiply by 10 in our base 10 number system, it's going to move this decimal to the right one place. So we're going to get 7200, so 7,200. But now here we've got 7.2 times 10 to the negative 3. So again, in an early part of this section, we know that a negative exponent we think of as a reciprocal. So 10 to the negative 3 is 1 over 10 to the third. So this is 7.2, and then 10 cubed we said was 1,000. So now we're taking 7.2 and dividing by 1,000. So again, in our number system, let's clear off what was there. So again, let's start with 7.2, and let's divide by 10. And we can see that the decimal moved to the left one place. And if we divide by 10 again, it moves to the left yet another. And if we divide by 10 again, it moves to the left yet another. Okay, so if we were to take 7.2 and divide by 1,000, we get 0.0072. Okay, so every time we're dividing by another 10, so we had 10 times 10 times 10, we're dividing by 10 3 times over. Okay, that decimal place moves to the left each time. So when we took 7.2 divided by 1,000, we got 0.0072. But again, keeping in mind with our base 10 number system, every time we divide by 10, we're moving yet another place to the left. So this one we're going to move 3 places to the left, unlike this one where we move 3 places to the right. All right, now, next semester, especially when we deal with a lot of probabilities, we're going to see answers that look like this on the calculator. And this is the calculator's way of telling us that it has put something in scientific notation. So this E actually stands for the exponent on a base of 10. So 2.2 E minus 6 actually means 2.2 times 10 to the negative 6 power. Okay, so this means 2.2 times 1 over 10 to the 6, just 2.2 divided by 10 to the 6. Okay. So again, every time we divide by 10, we're going to move this to the left one place. And so in this case, we're going to end up moving that decimal to the left 6 places. So this is going to give us 0.0000022. So negative exponents, we're going to be moving that decimal to the left because we're actually going to be dividing by a base 10 number. And here with that positive power on 10, we move the decimal place to the right. So in Math 162, we will see many times when we make probability computations that the result is so small that the calculator will give us an answer in scientific notation. Even if we didn't ask for it that way, it's just going to do it. So we need to know what that notation means. Okay, so it's more important actually that we know the example we just completed in example 7. We aren't going to, but in some of your science classes you will be writing really large and really small numbers in scientific notation. So example 8 is important for those courses. Okay, so we want to write the following in scientific notation. So scientific notation, we need to start first, and we need to have a single, it's got to be non-zero digit in front of the decimal. So if we start with this first number, to put it in scientific notation, it would first need to look like this. Okay. Although we tend to not worry about all of those ending zeros. Okay, 1.496, but it's got to equal what we started with. So this is times 10. To get it back to here, I would have to take this decimal and move it to the right 1, 2, 3, 4, 5, 6, 7, 8 places. Okay, so 1.496 times 10 to the 8th would give us this number that we started with, 149,600,000 kilometers. So again, this next one, again, we want to move the decimal such that there's just one single non-zero digit in front of the decimal. So for this one, that would be 2.2. Okay. But again, what we write here has to be equivalent to the number that we started with. So to get from 2.2 back to what we started with here, we'd have to go to the left. 1, 2, 3, 4, 5, 6. So this one would be 2.2 times 10 to the negative 6.